Okay, so 35, 36, 37, 38 are all speaking about probability distribution, so we'll do those all in one. So there's two major rules for probability distributions. Those two rules are every probability that's right? Must lie between 0 and 1 inclusive. Probability has to be between 0 and 1. 0 means a probability of 0 means an event never occurs. A probability of 1 means an event always occurs. Has to be between 0 and 1. There's no negative probability. There's no probability greater than 1. 2, the sum of the probabilities of all possible outcomes must be 1. If I add the probabilities of all the outcomes in a sample space in a distribution, must be 1. The sum has to be 1. Those are the two rules. So let's apply those to these 4 problems and see what exactly we come up with. So the first one, we have to put in this value here. So the probability that some random variable equals 5 is 0.57. Probability of 6 is 0.13. Probability of 7, we don't know. Probability of 8 is 0.17. So the first checks, right? Every probability has to be between 0 and 1. All of these are the probability that we choose also has to be. More importantly here, the sum of the probabilities of all of these outcomes has to be 1. So let's add what we have. 0.57 plus 0.13 plus 0.17. And I can say plus x equals 1. I can do it that way. Let's do it that way. Plus, let's not call it x. Let's say plus the probability of 7. It has to equal 1. So if I add what we have, this added together, that's 0.70 plus 0.17 is 0.87 plus probability of 7 equals 1. So the probability of 7 has to be 0.13. That's our missing probability, 0.13. 36, we're following the same idea, but we have to write the distribution. The problem's going to look very similar to this when we're done, but we just have to write this out ourselves. So let's say x, and let's say the probability of x. So we've got 3 possible values here, 2, 3, or 4. Probability of 2 is just going to be x over 9, whatever it is, right? So this is 2 over 9. Probability of 3 would be 3 over 9, right? Just that value over 9. Probability of 4 is 4 over 9. Now determine whether this is a valid probability distribution. The first rule holds. Every probability is between 0 and 1. Now the sum, let's add it up and see if we get 1. 2 ninths plus 3 ninths plus 4 ninths. 3 and 2 is 5. 5 and 4 is 9 over 9, which equals 1. Yes. Valid probability distribution. That's what we're checking for. Once we check those 2 rules, once we see those 2 rules hold, then we're good to go. Then that's what we're doing. And we're doing the same for 37 and the same for 38. Let's see. X. Probability of X. So X, we've got 0.1, 0.3, 0.6. Right? We've got those three values. And it says the probability of x equals x. It just equals this value. So the probability of 0.1 is 0.1. The probability of 0.3 is 0.3. Probability of 0.6 is 0.6. Every probability is between 0 and 1. Let's add them up. And if we get 1, we are golden. 0.4 plus 0.6, that's 1.0. Yes. Valid probability distribution. Exclamation point on that one. 38, we're doing the same thing. X, probability of x. So the x values for this one are, whoops. X values here are 2, 3, 5. So in this case, we're writing these values over 11. So 2 over 11, 3 over 11, 5 over 11. Each of them are between 0 and 1. Perfect. Let's add them up, see if we get 1. If we do, we'll be 3 for 3. 3 plus 2 is 5. Plus 5 is 10 out of 11. That is not 1. So no. Not valid or invalid. Invalid? Invalid? Huh. Not a valid probability distribution. 2 of them. 3. Yep. So that's 34 through 38.